Let's do 19th. That's easier to understand.
Okay.
Question 19. Can you read the question?
Evaluate the line integral C. Integral C.
Yes.
2x plus y dx plus x minus y dy, where C is the union of the line segments from negative 1 to negative 1 to 0 to 0. Then from 0 to 0 to 2 to 0. And finally from 2 to 0 to 2 to 3.
Okay.
Oh, this is the new one, right?
This is a new one. This is a different type of integral. First of all,
Okay.
it's not a regular integral. Okay, it is sometimes written as a circle,
Mm-hmm.
an arrow like this, and then there is a C. Okay.
Okay.
Now this C is a path of integral.
Mm-hmm.
Okay. This can be a line or this path can be a curve. It depends. Either is fine.
Okay.
So line integral is a little bit misleading because this integral can be solved along a line or this integral can be solved along some path. And that path is C. It could be line or it could be curve.
Okay.
And then this integral is called as a line integral. Okay. So
Okay.
line integral, what is the difference between line integral and regular integral? Line integral is evaluated along a path. And the path plays a very important role. And the path is said to be, this is -1, -1.
Mm-hmm.
That's here. To 0.
Mm-hmm.
That's your first path, right?
Yeah.
Okay. What is the next path?
Second one, it's 0 to 0. Oh, 0, 0 to 2, 0.
2, 0. Where is the 2, 0? Where is it?
It's on the X. Yeah.
This is your second path.
Mm-hmm. Other one, 2 to 0 to 2 to 3.
2, 0 to 2, 3.
2, 3.
2, 3 is going to be where? 1, 2, 3. 2, 0 to 2, 3.
Mm-hmm.
So line integral is always evaluated along path. So I'm going to just going to call it C1. I'm going to call it C2 and I'm going to call this C3.
Okay.
Okay. And I'm just going to call this as IC.
Mm-hmm.
And now this path, the zigzag path here, from here to here to here to here. Okay. The entire path is broken into 3 parts.
Mm-hmm.
So now just remember the point that you can always do this, that when you want to find out integral over the path C, it can be integral over path C1 plus integral over path C2 plus integral over path C3.
Okay.
It is sum of these 3 things.
Oh, we'll do for everyone.
We will
Okay.
do it piecewise.
Okay.
So now you tell me that if you look at this, this, you know, this is y equals x lines.
Mm-hmm.
Okay. So for IC1, I'm talking about this one right now.
Okay.
That is line integral over path C1.
Mm-hmm.
That is y equals x.
Mm-hmm.
The path C1 is y equals x, right? 45-degree line is y equals x.
Yeah.
Now what if I differentiate this? Do you see dy equals dx?
Yes.
Okay. Now what we do is, we write IC1 from IC, from this. But
Mm-hmm.
for IC1, do you see the condition? For the IC1 has a condition here.
Mm-hmm.
The condition says that y equals x and dy equals dx.
Okay.
So for IC1, I will say this is the integral where y and x are same. So I'll write this as 2x plus x. I replace this y with x. Because I know y and x are same. At least on this
Okay.
part.
Okay.
Okay, I hope you get that. So dx, I'll leave it as it is. Then I'll write x and y is x only. So this y also replaced by x. And then dy is nothing but dx. You see that here?
Yeah.
Basically, what I've achieved is I reduced the entire integral into one variable.
Okay.
Note one variable. That is x. So we got all this in terms of x, right? Now you tell me, what do you think is the limit of x for this integral? Now, if you see our path, the path is only the green part.
It's 0 to -1.
X is -1 to x is 0.
0 to -1 to 0.
-1 to 0. And you have to always follow the arrowhead. So you can't write 0 to 1. You should write -1 to 0. You can't write 0 to -1.
Okay.
Because you're going from here to here. The arrowhead is very important.
Okay.
So that's it. So x is going to go from -1 to 0. Your x will cancel out here. That becomes 0. Tell me what is IC1?
It's x plus x squared over 2.
-1 to 0. What are you saying? 3x.
X. Oh, yeah.
Tell me. IC1.
X 3x squared over 2. Yeah.
That will go from
-1 to 0.
That will be 0 minus 3 times -1 squared over 2. That is 3 over 2.
3 over 2.
That's how it is done. So now, please understand, we have only done IC1.
Yeah.
Of course, very similarly, in a similar way, we will solve for IC2. Now you say I write. Okay. It's going to be exactly on the same line. The whatever is written over here, okay, it's going to go exact same. Okay. So let me
for C2,
use different color code and you tell me.
Okay.
You tell me, okay. Like exactly like this. Tell me for
IC2
IC2
line integral,
that is line integral
one's path
over path
over path x equals y equals x.
that is it y equals x or is it y equals 0?
No, y equals 0. Yeah.
Because now we're talking about this path, right? And this line is nothing but x-axis. And this has got equation y equals 0.
Yeah.
So this path belongs to a line which is y equals 0. That's x-axis. So condition is y equals 0. If y equals 0, what do you think dy is?
0.
So now, what is IC2 going to be? Wherever you see y, you put 0.
0 to 2.
Oh, we'll see that.
No.
Yeah, correct. X will go from 0 to 2. But you can always write limits later. Now put y 0. So you get 2x plus 0
dx
plus 0.
plus 0.
Because dy itself is 0.
Yeah.
This will become integration of 2x is going to be x.
X. Yeah, 2 x.
It's going to go from
0 to 2.
4. So I have IC2. Done. Now, one last part. You tell me, I'll write down. For
For C, I see 3.
IC3,
Line integral.
that is line integral,
Over path C3.
path C3,
Y equals 3.
that is x equals 3.
Of x equals 3.
Differentiate, you get dx equals 0. So this is the path, and this path has got x equals 2. It's x equals 2, not 3.
Yeah, I look at the y-axis.
Right. X equals 2 and dx equals 0. Tell me about IC3.
Integral.
So you'll use this integral, right? And then put x as 2 and dx as 0. Integral, this will become, first part becomes 0. Plus 2 minus y.
2 minus y dy.
Now what are the limits of y?
Limits of y. 0 to 3.
Perfect. So you get this equals 2y minus y square over 2. Go from 0 to 3.
6 minus 9 over 2.
6 minus 9 over 2, which is 9, 6 to the 12, 12 minus 9 would be 3, 3 over 2. Right? Let's call this 1. Let's call this 2. Let's call this 3. Let's call this 3. Let's call this 4.
4.
From 1, 2, 3, and 4. I equals negative 3 over 2. This one
Plus
plus 4.
Yeah, the answer is 4.
Plus 3 over 2. I is 4. Is it matching? Perfect. This is how the line integration is. So you basically line integration is dependent of path. That's the first point you should note. And depending on what kind of path you have, okay, you will get a condition. Like the first path, I've color coded this whole thing. The black is IC1, the blue is IC2, and the red is IC3. The first IC1 was along this line.
Okay.
So it followed a rule that y and x are equal.
Okay.
So I got dy also equal to dx. I put those conditions back into the integral, and I get a new integral. And
I got it.
The new integral is no more a line integral. It is the regular school integral that we've learned before. Really small. This integral we already and done. Then you simplify this.
Okay.
This can